This lesson talks about variability. Variability, how does something vary? How does it change? So just a quick review, we have a data set right here, and we want to find the middle value. So the median is a measure of center, and we can also use the mean as a measure of center. So the median is the middle value in the data set. So if we cross off all of our values from the outside, we can get the middle value, the median. So we will cross off, cross off, cross off, cross off, cross off, cross off, and we'll end up with the middle value, which is 23. So we can use that as a measure of center, and it's better to use the median as a measure of center when there's not a value that's extremely high or extremely low, because remember, if we use the mean as a measure of center, we have to add all the numbers up in the data set. So if we have all of the add up all of the values in the data set, and we have an outlier, one value that's a little significantly away from all of the other values, and once we divide it by the total numbers in the data set, we're going to get a number that's slightly not a better measure of center. So in this case, I would probably use the median as a measure of center over the mean, because 10 is not really close to 20 through 28. 23 is a better measure of center, is a better number that represent every single number in the data set other than the outlier. Even though these two numbers are closer together, you want to be able to identify when do you want to use the mean and when do you want to use the median as a measure of center. And in some cases, you might need to use the mode, the number that occurs the most. So this lesson talks about range, variability, how often the data points vary. So let's go to the key concepts for this lesson. So we kind of talked about this a little bit. So high variability, what is high variability? So high variability is basically when your data points varied highly. So if you look at this spread, we can see that the variability ranges from 1 to 10. So this will be considered high variability because our data points are more spread out. So since our data points are more spread out, we can say that this has high variability. Compared to this, which is low variabilities, the data points values are closer together. So this range is from 4 to 7. So since the range is closer together, since our data points are closer together, the data points did not vary as much. So we will call this low variability since the data points are closer together. And then what is no variability? Exactly what it means. That means the data points did not vary. That means everyone scored the exact same score. Everything is exact. Every data point value is exactly the same. That doesn't mean that that the question that was asked is not statistical. That just means that the results of the data did not vary. Sometimes when you get all of the same results does not mean that the data points didn't vary. So, or that doesn't mean that it's not a statistical question. Just like in class, if everyone get 100% on their homework, and my statistical question before I collected the data, before I found out everyone got 100%, what are students going to get on their homework grade tonight? That was my statistical question. And the next day when we went back to school, everyone happened to have 100. That does not mean that my question is not statistical, because someone couldn't have gotten a 0. They could have gotten a 25%. They could have gotten a 98%. But since my sixth graders are so smart and work so hard, everyone ended up with 100%. So that does not mean it's not a statistical question. So if you want to determine if a question is statistical or not, you have to ask yourself, could this vary before I collected the results? Did this question have the ability to vary? If that answer is yes, then that is a statistical question. All right, so we have some data sets here. We want to determine if they're high variability, low variability, or no variability. So this first data display, we can see that we have data points that are spread out. So this will be considered high variability. And then we have a data set here. Now this is a histogram, and I'm pretty sure some people would say this is no variability, but that is not true. This is actually low variability. Yes, this histogram right here is low variability and not high variability. Remember, histograms work with intervals. So if I put some intervals here, let's say this is 0, 5, let's say this is 10, let's say this is 15. So if we count by fives, all of my data points fall between 5 and 9, right? So since my data points fall between 5 and 9, I cannot say that all of these data points in here were 7s. I can't say that all of these values within this interval are the exact same. And since you cannot say that, since you don't have a data set, you cannot say that this is no variability. You would have to say it's low variability. Unless it's a constructive response question, it can be argued, but you have to state your understanding. So based off of the information that we have in this histogram, this data shows low variability. Now we have another data set. We have this box plot. So we have our minimum, maximum, median, which is Q2, Q1, the median of the lower half, and Q3, the median of the upper half. I'm going to say that this is high variability because if it was low variability, then all of my 5 boundary values would be right on top of each other. So I can say that this one is low variability because my 5 boundary values are more spread out. And then this one, this is what no variability looks like. This is no variability because all the data points did not vary. So since the data points did not vary, because they're on the exact same value, then we can say this is no variability. So if I were to put numbers in here, 3, all of the data point values are on the exact same number. So since all of the data point values are on 3, that means that the data did not vary. So this is no variability. And this is in your notes notebook. Make sure you're taking notes as we go through these. And go ahead and answer this one in your digits book and this one as well. And we're moving to part 2. So how do you measure variability? What if we can't determine? So we have a data set right here, and we can see that there's an outlier, and I hope you know that outlier is 40. So since there's an outlier in the data set, what should you use as a measure of center? Should you use the mean? Should you use the median? Or should you use the mode? You shouldn't use the mode because we don't have, the only number in this data set that repeats is 4. But it's still not a good representation of the entire data set. So we want to use the median or we want to use the mean. Now, since we have an outlier in this data set, we should use the median. The middle value is going to be a better representation of this data set because this outlier 40 is going to pull the mean closer to it. And that if you pulling something closer to you, you pulling the numbers away from the middle of the data set. So a better representation of the middle of the data set is going to be the median for this data set. So we're going to put this data. So we're putting the data points on the dot plot, and as we see, we're gonna see how the outlier affects the range. So we're putting all the data points, and look what happens when we put an outlier. So once we put the outlier into the data set, we can see that the variability or the range of the data set increases. So this measure of variability increased based on the outlier. So now that we know, we can think, okay, that must mean that the outliers affect the variability. It also affects the range. So now let's look at what range is. So range is going to be the minimum value and the maximum value. You need those two. You have to subtract the minimum value from the maximum value. So in this case, we have 40 as the maximum, 2 as the minimum, and then we have to subtract them and we'll get the range, which is 38. So in this lesson, we're talking about the range. In the next lesson, we're going to talk about interquartile range, which is the range of the quartiles. So range is just the highest value minus the lowest value. What is your range? How high can you go? What is the space? Now we want to find, this is in your notes notebook, make sure you go ahead and do this. So we want to find the range of the data set. So we have our first data set right here. So we need to identify the highest and the lowest value. Never assume that your highest and your lowest value are going to be the first and the last number in the data set. You have to make sure you look through the data set and get the smallest number and the lowest number. So if we look at the first one, we have our data sets. So our maximum number is 32 and our lowest number is 24. So once we subtract them, we'll get 8. So the the range of the first data set, the orange is 8 units. And then we're moving on to B, the second one, the purple. So we have to put our data set values in order so we can get the highest value and the lowest value, which is 0, the minimum, and the maximum is 89. So since range is the maximum is equivalent, the range is equivalent to the maximum value in the data set minus the minimum value, we can subtract those and see that the range is going to be 89 for purple. So go ahead and write that down. And then for the green, we have our data set. We put our data set in order so we can easily see the lowest value and we can easily see the highest value. And then once we subtract them, we will get the range. So 35 minus 10 is going to be 25. So the range of our last data point is 25. Easy enough. Go ahead and find the range of this data set. Remember, range is the highest value and the lowest value. You have to subtract the two. The highest value is going to go first. Now, is the range affected by stray values? Please say yes. Because if you have a higher value, if you have an outlier that's a higher value, it's going to increase your range. We saw that in the first part. So go ahead and answer that question in your digits book. And then we have this last part. So we have a science experiment and they want us to find the range. So here is the data set right here. So we've seen the data set. Now we have to find the range and we have to describe the variability of the data set. So how did the data points vary? So the range is going to be the highest value minus the lowest value. So we have 26 minus 12, which is 14. And the range, a range of a drop of water is a wide range in this situation. So data set has high variability. So since the range is high, we can say that the variability is high. We don't have any outliers for so much. I mean, 12 could be considered an outlier. I would say it could be. So if we take 12 out, how would that affect the range? Then we would have to do 26 minus 19 to see how 12 would change. Once you subtract 26 and 19, you get 7. So a range of 7 versus a range to 14, I could say that 12 could be an outlier. So in this case, we want to use the median as a measure of center because the median will better represent the data set because 12 could be considered an outlier. So this data set is going to have high variability since 14 is such a large number. And the last question, go ahead and answer this question in your digits book. So you have to pick the statements that are true. So if you look at the statements, you have two numbers for range. Please don't pick both of them. You have high variability or low variability. Please don't choose both of them. You're either going to be high or low. You're either going to be 1200s or 2900s or none of them at all. But if we look at our data set, we can see that the range is 29 because the highest value minus the lowest value is 2900s. And we can say that that's low variability because 2900s is such a small number. So we would say that is low variability. So we will pick 2 and 4. Now we're moving on to interquartile range. And you can also tell variability using the interquartile range because that interquartile range is going to be that middle 50%. So let's just go over some things that we need to know in order to get the interquartile range. So first you need to know your boundary values. So if we look at this data set, point score per game, we can see the 5 boundary values. And remember, to make a box plot, you need 5 boundary values. Where this point right here is the minimum, and then we have the maximum, which is the highest point in the data set. The minimum is the lowest point in the data set. And then we have this point in the middle of our box, in the middle of our box right here, which is this point right here is the minimum. That's also called quartile 2. It's the median. So this is Q2, also known as the median. That's the middle value in the data set. So if you cross off all the values, you're going to end up with the middle value, which is this 29 right here. So this is the middle value. 6 is the lowest value, the minimum. The maximum is 39, and then you have to find the middle of the upper half. So the upper half is 23, 21, 18, 17, and 6. So if you cross off and cross off, the middle value of the upper half is going to be quartile 1, which is this point right here. And then we want to find the middle of the upper half. So everything that's considered the upper half is 30, 32, 35, 37, and 39. So you're going to cross off, cross off, cross off, cross off, and then quartile 2 is going to be this 35 right here. So we can find the range of the data set, which is 39 minus 6, to get 33. But to see how our data, to see if our data has high variability or lower variability. However, outliers really affect high variability. When you have extremely high values or extremely low values in a data set, the outlier will really affect the variability. So interquartile range is a better measure of variability because it's that middle 50% of the data, and it's not affected by outliers. So if we look here, the range, the interquartile range is going to be the distance from the the quartile 3 and quartile 1. So you subtract the quartiles, and then you'll get the interquartile range. So if you break the word up, then you can see. So the interquartile range, the IQR, is a measure of variability in a numerical data set. The IQR represents the spread of the middle 50% of the data. So you find the interquartile range by subtracting the first quadrant from the third quadrant. So in this case, we will subtract 18 from 35. And then that'll give us the interquartile range. So let's see what they have. So we have 35 and 18. And interquartile range is third quartile minus the first quartile. 35 minus 18 is 17. So the interquartile range is that middle 50%. Let's see how that compares to the range. So the range is the subtracting the minimum from the maximum. So in this case, we have our range of the data set, the highest value minus the lowest value. So we have range is equivalent to the maximum minus the minimum. So in this case, the range is 33. Now the interquartile range is a better representation of the spread because it's that middle 50%, and we can see that 6 is an outlier, so it's drastically affecting the variability or the conclusion that we can draw from variability based on the range. So does the data set have an interquartile range of 16? So in order to find an interquartile range, you have to look at quartile 3, which is right here, and quartile 1, and you have to subtract them. So once you subtract them, you'll get the interquartile range, and if it's 16, obviously you will pick that one. So let's look at the first one. So A, we have the third quartile is at 55, and the first quartile is at 42. So interquartile range is the third quartile minus the first quartile, so we subtract 55 and 42, and we end up with 13. So we would not pick that one because the interquartile range is 13 and not 16. Now let's move on to B. So we're looking at the interquartile range, so we have to get the range of the quartiles. So we're looking at quartile 3 and quartile 1. So we have those values. Interquartile range is going to be the third quartile minus the first quartile. Once you subtract, you get 10. So we wouldn't pick this one because the interquartile range is 10 and not 16. And then we have C. Our interquartile range, our third quartile is 115 and our first quartile is 99. Once you subtract them, you'll end up with 16. So this is the only solution that we should pick because the interquartile range is 16. So if I ask which one has the highest variability out of the three, we would have to say that C has the highest variability because 16 interquartile range is higher than the other two box plots. Now, if I said which one has lowest variability, we would have to pick B because 10 is a smaller, it varied low at a lower rate. So since 10 is smaller than 13 and 16, we could say that B has the smallest variability. Go ahead and answer this one in your digits book. Should be fairly easy. Alright, so this is another question. The data set shows the highest pitch measure in hertz the various animals can hear. Find the interquartile range of the set of the highest pitch. What does the interquartile range tell about the highest pitch versus various animals can hear? Alright, so the first thing we have to do is find quartile 3 and quartile 1. We have to put our data set in order, find the middle value, find the middle of the upper half, find the middle of the lower half, and then we can find the interquartile range. So here's our data set right here. We have our pitch spread out. We have our highest value and our lowest value. We're crossing them off. So we can find that middle value. You keep crossing off until you find your exact middle. And since we have two values here, we have to add them up and divide by 2 to get the middle value, which is quartile 2. So the median or the middle value of the data set is going to be 37,500. Now that we have the middle value, we need to find the median of the upper half and the median of the lower half. So everything that's shaded now is considered the upper half. So we need to cross off until we find the median of the lower half. So we have two values left over. So we need to add them up and divide by 2 to get the exact middle of the upper half. And once we divide by 2, we end up with 10,250, which is quartile 1, the middle value of the upper half. Now we need to find the middle value. No, that's the middle value of the lower half. Now we need to find the middle value of the upper half, which is quartile 3. So we cross off, and we have two values left. So we're going to add them up because you have to find the middle of the two values. And then you have to divide it by 2 to end up with 70,000. So we have quartile 1 and quartile 3. Now we can find the interquartile range once we subtract. So the third quartile minus the first quartile is going to be 70,000 minus 10,250. And once we subtract, we will end up with our interquartile, which is 59,750. And that is the interquartile range of the data set. Now, since our interquartile range is such a large number, we can say that this data set or this statistical question, the highest pitch of various animals, has a large variability. Because the interquartile range is so large, the pitch that the animals can hear varies at a high rate. So this is considered as high variability since the interquartile range is such a large number. This question is in a digits book. So the interquartile range of the set of the of the lowest pitch that various animals can hear is 245 and 5/10 hertz. The interquartile range of the set of the highest pitches that the same animals can hear is 59,750 hertz. Which set of pitches is more consistent among these animals? Explain. The interquartile range is more consistent because it's that middle 50%. The middle 50% is not affected by outliers, just like the median. So since the interquartile range is not affected by extremely high or extremely low values, or in this case, extremely high or extremely low pitches from the different animals, that's why the interquartile range is much more consistent versus the range, because you may have one animal that can hear at a very high pitch, which is why we get this high number right here for the highest, the range, or the highest pitch. So the interquartile range is more consistent than the range. And then we have this last part right here. So the data set shows the maximum lifespan of various animals. Determine whether the statement is true. So the median of the data set is 12 and 5/10 years. So the first thing we will have to do is put the data set in order from least to greatest, and then we will have to find the middle value of the data set. Then we will have to find our quartiles, first and third, and then we can find our interquartile range. So we can't do any of these questions until we find our 5 boundary values, if you will. All right, so for part A, we have the tiger and the cat as the middle value, and these numbers are already in order from least to greatest. Great. So we have our numbers in order from least to greatest. So the tiger and the cat are the two middle values. So if we have 2 middle values left, you have to add them up and divide by 2 to get the median. So we have 28 as the median. So that will be false because it's not 12 and 5/10. So since the median, the middle value of the data set is 28, the numbers that's considered as the upper half is going to be 26, 24, 21, 9, and 4. So the only things that you do not include as the upper half is the actual median itself. Even though 26 and 30 made up the median, they are still considered a part of the upper half and lower half because they are not the median themselves. And 2 things made up the median. So now in order to find our quartile 3 and quartile 1, we have to cross off everything that's considered our lower half. So the only thing what's considered a lower half is everything except the median. So since the median is 28, we're going to cross off 26, even though it made up that 28. We're going to cross off 4. We're going to cross off 24 with 9. And then we have our middle value of the lower half, which is 21. So quartile 1 should be 21. And the first quartile, the middle lower half of the data set, is not 52. So that statement is false. It's 21. Now let's find the middle value of the upper half. So I'm going to do the same exact thing. So what is considered the upper half? Everything that's higher than the median, and the median is 28. So we have 30, 52, 65, 138, 211. So I'm going to cross off 30 with 211. I'm going to cross off 138 with 52. And then my quartile 3, the middle value of the upper half is going to be 65. So I'm going to check to see if that is the value. So I'm going to check to see if that is true for C. So the third quartile is the middle value of the upper half of the data set. In this case, the third quartile is 65. So C is true. Now the last part is to find the interquartile range. So interquartile range is the highest value minus the lowest value. So if we look here, quartile 3 is 65 and quartile 1 is 21. So 65 minus 21, and we end up with 44. So the interquartile range is 44, and that's what they said. So this statement is true. So just a series of steps, and there you go. So the first thing you have to do is make sure you put your data set in order. If your data set is not in order, you cannot find your 5 boundary values accurately. All right, so go ahead and answer this question in your digits book. Make sure you put your numbers in order from least to greatest first. And then you can answer this question also.